So maybe they can see that if I turn the light on. Hey, folks, we're going to get the lights on. I'm going to get the cart and finish some stuff on the cart.
I think I already lost the paper.
Wow, we got it this morning. I've almost ruined mine, but I haven't lost it.
I almost lost mine as well. I just noticed that I was like looking through my backpack and trying to get it. Okay.
You're bad at that.
Look, my
Backpack's a bit messy, just a little bit.
bro, mine used to be so bad. It's gotten better now, but holy fuck.
That's
I would just like to say, you should become an art teacher.
I think I should too. Why would the pictures go through, bro? I go on data on those now.
Oh, also the phone back that you video of your.
Is it actually, are they like on yet or picture? Oh, what's your arm? Hello.
Guess what, guys? I found it.
We're so proud of you.
Good job. Mine, have you seen how you're sending them? Or?
Yeah.
I want to try
It's not what my dad.
When I get home, which is
7
like
years.
Here, I'll send mine. 9 weeks last. Oh, yeah, we did. Why don't you connect to the school?
Oh, wait, did you send?
They did send. I have no idea right now. I sent mine too.
You might know you can
You just heard my phone buzz.
That's how rough in this space. I play all the phones like here.
Yeah, I was dragged away from the soccer field for basketball.
You like soccer or basketball, right?
Soccer. I'm better at soccer. I enjoy playing basketball.
I don't like basketball.
When I
Go.
yeah.
Oh my god.
You know what we should play tomorrow?
What?
Okay, and there's some folks at home. Good. I'd go get the cart. So let me write down my people here. Here and here. I'm missing Erin. Let me write her down. But I knew I'd be missing her. And I'm missing Ms. Morrow is also not there. Okay, I got Corsine this time. Good. I've got Anton. I've got Isaac. And Matthias, hello. I've got Inessa. I've got Isaiah. And I've got Leo. Good. Okay, so let's go ahead and begin. In the first station we had yesterday.
Today, this morning.
Seems like yesterday, it was so long ago, sorry. In the first station from this morning, either folks at home or folks here, we had a setup that was basically what? What's the phenomena that we were doing or getting in station one? Ethan?
I think it was the generator effect.
Generator effect, you got it, good. What's a way I can increase that effect? Give me one way. Hannah, what's one way?
Here. I swear I was
First station?
Move the coil faster through the magnet.
Yeah, there you go. Move the coil faster through the magnet. That'd be one way. Give me another way. Ayala. A stronger magnet. Good. Let's see if somebody at home has a way. No, not yet. Okay. Kai.
Add more to the coil.
Add more loops to the coil. Good. And the one remaining one is what, Sina?
Move coil faster through the magnet.
Right. So move coil faster through magnet or magnet faster through coil. Either one doesn't really matter. They both increase the effect. Super. Number two, we also got the generator effect. And what was different between 1 and 2? What was a little different in 2? Isabella.
Well, the power is less because you're spinning the magnet outside of the coil.
Okay, I spun the magnet outside the coil. For folks that weren't there this morning, go get this file. If you haven't run it off already, it's in the live stream. It's about 10 or 12 messages back, and it's this. It's this more or less lab that we're doing, okay? It's got nice pictures on it. And this afternoon we'll finish in 3 and 4, and we need to do another one. Good, and Inessa answered it as well. The magnet was next to the coil, just what Isabella said. And we still got electricity. And good. Let's jump down to 3 because we need some time here. For 3, this is again a what? Aslan.
Code number 3,
Yeah, it's a what?
generator.
It's a generator. And I'm going to just show that again for folks at home. There were 6 of you that weren't there. Hey, I got another one. I got Abram.
Where's the wrong?
That's okay.
Might be the wrong class, buddy.
It's okay. It's all right. That's all right. No, Abram, but you missed the other one anyway, so you may want to stay here, Abram, because you did miss the other one as well. So this may not be a bad thing. Okay, here it is. There you go. So there it is again. And, doggone it.
No.
Okay.
Nothing about the charger.
Are we having a problem?
No.
Okay, can we pay attention? Thank you. Good, okay. Here we go. So, I'm going to turn this thing, and I've got this guy, which is a coil, obviously, and then I got this thing. And folks who are here can tell me what this thing is. Maybe a couple at home are here this morning as well. What must that be? Good, I got a couple of you got it. Ethan?
Well, magnetic, that's great.
Good, that's a magnet. Good. So I got a magnet with a magnetic field inside of it, and I'm spinning the coil in there, and by gosh, I get what? Okay.
Electricity, voltage.
Yeah, thank you. I get a voltage, so I've got some electricity. Can you tell I'm trying to go really fast, Kai? I'm sorry. Okay. Shall I slow down before I pass out, people? Probably, huh? Okay. And magnet, exactly. Thanks, Isaiah. He knew that as well. Oh, I got Devontae there. All right. He's there. Good. Very, very good. Thanks for joining us, everybody. Right, so a lot of you knew that was a magnet inside spinning magnetic field to make a generator. Good. Okay. Let's go to number 4. Oh, shoot. Okay, so the slip rings, I walked around and showed you this morning, right? This plastic white thing. Yeah. Folks at home, it's this plastic white thing. And remember, plastic is not a good, right? So why is that in there? We had some guesses. Did you think about it? Why is that in there? Maybe, Isabel, take a guess.
Maybe to prevent the voltage from going past it or something.
Going past it. The voltage is not a thing that's moving. So the voltage is not really a part here. Well, think about it. When I got electricity sort of being conducted, but then when it hits that plastic piece, what happens? It stops conducting. Exactly, Ayala. So what's going to happen is then it turns over. So can you guess, Ethan, what might be going on?
Well, I was just going to say that it definitely has to do with the fact that the plastic piece stops the electricity supply.
And you're right. Electricity doesn't go through plastic well. It's a poor conductor. Right, it stops. Isaac said that as well. Leo said conductor, right? So it's a poor conductor, and probably what we're doing is enabling us to form electricity by doing this. What kind of electricity? Hence, voltmeter was doing this. Or sorry, what sort of current was that? We talked about this morning.
Yeah.
We talked about, was it
Alternating current.
alternating current. So I think the slip ring is allowing us to make alternating current, okay? Okay, because it alternates which part of this little metal piece is being conducting, okay? All right, that's all we need to know about that. Let's go to our last one. I'm going to show this to folks at home, and then I got to have folks here come up really close because it's hard as heck to see. I also don't want my laptop, because I'm going to hang a big magnet here. I don't want that near my laptop. Bad idea. Okay, so here we go. Ready? I'm hanging a horseshoe magnet. Whoa, I'm trying to hang it. That'll work. Okay. Just don't want it to fall over. I got this guy. And there's a big coil, right? Big coil. And at the other end, I really need to plug it to what? Can you guess what I need to? Actually, I don't need it. You know what I could do is just make it one loop. Tell you what, let's just make it one so it looks more easy to see. We're gonna make it one lead. You do that? So one big lead. Remember that, folks? One lead, long, yellow, okay? Okay, now, what do they want us to do with this last one? Can you guess? How about Alicia? What do you suppose from the picture? What do they want me to do here? Station 4. Yeah. Or actually, I'm not. That's kind of crappy, isn't it? I'm actually not gonna move the magnet, I'm gonna move
Maybe the string, the metal part?
the coil. So I'm gonna move the coil, and I'm gonna try and move it in and out of the magnet without touching the magnet. So this is the part, I'm gonna do it once for the folks at home, then I'm gonna have all you come up so you can see this, all right? Okay, so. It doesn't happen a lot, but I hope it's happening some. Whoa, not much at all. Try this in the right one. Let me try this one. Maybe it's that one for this guy. Yeah, I think that was the problem. So it's doing a little bit, tiny bit, little tiny bit, magnet. So why would the magnet move a little bit? It's not much, it's just a tiny bit. So folks at home can answer that too. Why is the magnet going to move just a little bit? It's kind of a strange question. All right, folks here, come on up so you can see this a little bit better. And I hope it actually does it. I think I want these two. Now it's actually doing it. So a little bit, and when it does it, it actually moves not like this, but side to side like this. At what angle, can you guess?
Right.
Yeah, so 90 degrees, right angle. Yeah, like everything's been, right? That kind of weird. Did we do this already? Okay, we did that. Okay. Okay, so essentially, let's figure out what's going on, everybody. Maybe folks at home know as well. Yeah, it's getting pushed by the electric field. Well, kind of. Let's see. That's a good place to start. Let's see what Inessa said. It's attracted or repelled by the current. I don't know. Yeah, it's a good place to start. Electric field, current. Something's doing something to this. So let's think about it. Well, as I put this in here, what's probably happening in the coil, Sina? You got it. So I'm making electrons go one way or the other, right? Back and forth. Those moving electrons, that current, as we call it, must be doing what to screw around with the magnet? Must be creating a what? Another magnetic field. So it turns out when electrons move, they also create a magnetic field. And that interferes with this magnetic field, doesn't it? The one from the magnet. And it makes the magnet go, whoa, and we call that word in physics, it deflects. Deflects, if you had that before. So let's write that a little bit, everybody. So when we push the coil back and forth, the magnet deflects a bit. maybe I'll write a little bit with that one too, because that's kind of a hard one. So we're at station 4. Oh. So when coil moves in and out of magnet, big magnet, oh, no, it's the only magnet. Magnet moves at 9 degrees or perpendicularly. Why? Electric current created a second magnetic field. That deflected the magnet. That's a lot for that little space. I'm sorry I didn't give you more space for that last one. Let me read it for folks at home too, because sometimes it's hard for them to see the board. It says, when the coil moved in and out of the magnet moved at 90 degrees. Why? Well, the electric current created a second magnetic field that deflected the magnet. That's what we think going on. Good. While you're catching up, I'm going to get my next demo ready. More demos you can shake a stick at. Okay, I need the power cord. I'm going to go on. I don't want that to go on. Good. I better plug in my laptop. The audio is to the people at home. All right. Okay. Let's get this sucker out of the way.
What's the last question?
Oh, read me the last question, Isabel. I'm sorry, I didn't see that. Go ahead.
What forms of energy are converted?
Okay, well, I moved something, so we start with what sort of energy is that? When you move something?
Kinetic.
Yeah, kinetic energy, okay. Then go from there. What happened once I did that, Isabella?
Form electrical energy.
I form electrical energy, and then that made a magnetic field that made the magnet move a little bit. So we're back to kinetic energy. So I got what? Kinetic to electrical to kinetic. So you can fill that last question in the sheet there. Okay. All right, you with me, Hannah? Last question, you want to fill it in?
Yeah.
All right, stay with me. Okay, all right, now, let's get this thing where everybody can see it. This is a power source. It's a little different than others I've showed you. It sends out a special voltage, whatever I want. Then I got this thing. Here. Here's your. Hold on for a second. Whoa. It's not a magnet, but it's what? It's pretty heavy. It's, oh. Guess what it's made of? Not lead, but it's what? What color? Steel, yeah, it's made out of steel, big chunk of steel. So I got a chunk of steel here. It's not a magnet, okay? It's not, it's just a chunk of steel, but we're gonna do something with it, okay? All right, so you're gonna move up in a little while. Let me get this thing going first. So what I'm gonna do is, yeah. We're gonna make not less of a mess out of this. Is that helping? No, that's hurting. I think I'm beyond help here. My power is off. Good. Helps to not electrocute the teacher. Okay, now I'm gonna take this guy, 300. Everyone should be like, that's all I got. That's probably don't want that. I'm sorry, I'm looking for the right number of coils. That's why I'm dithering around here. I got two 600s. Do I have one back here? No. Well, I gotta use that, don't I? All right, so I got a 300 and a 600. So let me show everybody this. Okay, some of you saw this already. When we had this thing that says windings, 600 windings, it means if this was a meter long, it would be 600 of them. It's not a meter, but it's that rate of windings. So 600 windings, and this one here is 300 windings, okay? All right, and I actually want that here. So I'm gonna put that on this side. I'm gonna put this on that side. And just to confuse everybody, I'm gonna move that one over here, and I need another lead and another. Yep. Okay. All right, so I put them, I'm gonna put this one on 3. So I hope you remember how to read these from last year. So that the highest is 3, so I gotta think 1, 2, 3, okay? Here the highest is 15, so I gotta think 5, 10, 15. You can't see that. 5, 10, 15. Okay, let's see if it's gonna work. I gotta put that on top. Okay, here goes nothing. No, something's wrong. I want it on that. Maybe I want them both on direct. Well, that's certainly wrong. I think it was this one. I got my wires backwards anyway. No, that's closer to 1. And this is nothing. I got that backwards. Ah, fudge. All right. Everybody hang loose for a second. Let's see if I can get this thing going. By the way, look at that.
What?
Why? What do you suppose turn on the current did to this? Even though I just turned the current off, but I still got a bit of what? This is changed into a magnet. What I've created is called an electromagnet. Oh, I can pull it apart because I got the power off now, don't I? Yeah, I do. So I can pull it apart, but I had a magnet there for a bit. Okay, but that's not what I want to show you. I don't think I like that lead. I got a little bit there. Let's put them both on alternating. I thought it was supposed to be direct. God, I'm getting a little bit, but it's really pathetic. Okay, yeah, except it's not doing what it's supposed to. It's not doing anything, which is not right. Well, let's change out something else. In physics, when things go wrong, generally what we do is we change equipment. And sometimes that helps. If we get a piece that's not working very well. That's better. Oh, that's way better. That's way better. Okay, so here we go. I'm sending in. No, that's not better. That's worse. Why the heck would it be doing that? Should be going up. 600. Oh, Lord. Sorry. 600 and 600. That won't do anything. Let's change out to this side. I'm really done something wrong here. Okay, so that's going in here. And that's coming out here. That's right. It should not matter. I'll try it anyway. Yeah, it's matter. It's going the wrong way. All right, so it's not my problem. All right, I got about 1 volt in here. I got nothing. I don't know why. That looks all right. You see that? Still get almost nothing. I don't think it was here, but I'm going to try it. And I'm going from 6 to 3. So it should be half as much. Half as much. Maybe that's what I had. Let's try it again. Oh my, okay. This is ceasing to get funny here. Okay, let's try something different. Let's try 12. Now that's gonna do it. Okay. Okay, that side's working, so that's close at least. And this side's not doing squat. Why not? Really, it should be up here. Or at least a bit more. I cannot figure out what I'm doing wrong. Okay, I gotta just tell you what's going on. This thing is a transformer. And what it does is it takes voltage. I'm sending out 12 volts. And it did this last night on the, it's actually supposed to be 12. It's only sending out 10. And then what should be here, you'll have to imagine it. It should be here 10 volts, and over here it should be 5 volts. And the windings, I got 600 windings here and 300 windings here. So in other words, what does this device do if I had it working right? In this case, it lowered the voltage. Listen carefully, okay? I'm sorry I don't have it quite right, but it was 10 volts here. And on this side, I got 600 windings. On this side, 300 windings. Normally, if it's working right, this should be reading 5 volts. So the less loops, the less voltage. Okay, now, if I switch it around, which I'm going to do in just vain hopes, you know what I'm going to do? I got an idea. One last thing to change out. Let's change out the voltmeter. Shall we? Let's change that out. Okay. All right, now it doesn't work at all. I do not get what I'm doing wrong. Okay, never mind. Okay, if I turn this off, now I can rearrange things. And what I'm going to do is I'm going to switch these. Okay, and I'm going to put this side over here, and this side now over here. No, that's over the same thing. Now I got to switch the. Sorry, I got to switch the loops here. I got to switch this. Okay. $300, $600. So I'm going to then put it in here. Make it go up. All right, so then back to here. I don't think it's going to be any better, but I'm going to try it anyway. Okay. 15. 15. Let's let it fly. Well, I got some here this time. So here I got about 7.5. I should have 12. And over here I got nothing. And I don't know why that is. Okay, well, anyway, this time I got, oh, wait a minute. Sorry, let's try it again. Okay, I got these backwards. Oh, fudge. Okay, so forget it. You know what we're gonna do? We're gonna hand something out to you. Okay. Makes me mad. Oh, look at it, only got 10 minutes. Okay, so folks at home, this is in the live stream. I want you to find that. And it says Transformer. And just go and grab that. And I'm going to give one to everybody here. And we can at least get the idea, even if I can't get the demo right. It's hard from all the hours. Oh, no, I can't get it done today. Right, that's right. Yeah. Okay, so, yeah, more pictures. This time, it's really simplified. The source, the power is coming from the side that says primary. All right, so that would be like this. That's my power source. Then the side that's secondary. So for me, my primary is here. Okay, there's the power going in here. Secondary is this other side. And so there's the block, like my block. And what do you notice about the number of loops on each side? The number of loops. Alicia? Yeah, yeah. Yeah, in fact, they give you the ratio. Check out above the block. A 1 to 2 ratio. So, ideally, what would happen if, like mine was working right, if I got 6 volts and it's 1 to 2, how many volts should it be on the other side at the secondary? 12 volts. Can you just write that in there? Let's do the bottom. We're going to finish up the rest, but let's do the bottom one first. For the bottom one, Felix is there, pretty late. Okay, at least he's participating. Thank you, Felix, for that. Okay, and the bottom one, check out this one. It's a 3 to 1 ratio, and my volts coming in is 12 volts. So then folks at home can answer this as well. So using the logic of 3 to 1 ratio, like I was doing with Alicia a minute ago, what's going to be the voltage on the other side over at what's called the secondary? 3 to 1. Ethan, what do you think?
4 volts.
4 volts. So if you want to fill in 4 volts over here, that'd be great. And Devontae knew that. Good. So did Isaac. Thank you, gentlemen. Good. Good participation. Now, look back up here. They also tell you the amount of amps. And remember, amperes from 9th grade, no, you're in 9th grade, from 8th grade, is the amount of current, right? So you got to remember an equation to do this last part. Let's see if you can remember it from last year, all right? Let's get up so we can see the board. The equation is the equation for power. Power. See if it rings a bell for anybody. What's the equation for power? There's more than one, but you know one spelled?
Right. It's something like either amp over current or something. Wait, how is power measured?
Okay, good question. Power is measured in watts. Watts, megawatts, you might have heard of watts. Maybe your hair dryers has a certain amount of watts, right? So I need the equation for power. There is more than one. Let's see if anybody knows. No, okay. Ring a bell now?
Just kind of a guess, but volts over amperes or amperes over volts, one of those.
No, but there is one like that, and it's energy per time. Like a watt is, if you want this, 1 watt is 1 joule, which is the amount of energy per second. So you might have had that last year, I don't know. Okay, but the one I'm talking about today is this one, it's PIV. So what the heck is PIV? It's power equals, I was actually the letter for current. Thank you, Ms. Bell. Current, of course, V is voltage. So, here's the deal with this transformer. Is it off? Yeah, I won't electrocute myself. The power's got to be the same on both sides. Interestingly enough, the current and the voltage change here and here. They go through this block, and when there's a different number of loops of wire, the voltage changes, but therefore the current has to change too. So what I'm saying is, if I got a transformer, okay, for a transformer, the power in equals the power out. And they picked, on our sheet, we picked nice numbers. You ready? Here we go. In other words, for the top one, you ready? They gave you the amps, ready? 6 volts and 120 amps. Well, that's going to be the same as, what did you say it was? 12 volts, and that would be times how many amps to get the same number on the other side? Hint, if one goes up by 2, guess what the other thing's going to do? So, Ayala? Is that what we did? No, we just doubled it. Like 6 times, we did 6 times 2, you know what I mean? So we got 12, right? Well, what's going to happen to the 120? It's going to,
It's gonna double and become 240.
No.
What?
No.
So,
The power in's got to equal the power out. The
oh,
power
100
means is
is it gonna be on?
if the Isabel, 60 amps. So everybody write that down first, 60 amps. Here's the deal. If the voltage goes up and doubles, then the current is cut in half. See,
Where do we have?
somewhere up here. Like, look at across from there, Cena. You got a 6 volts, 120 amps. So let's do 12 volts and 60 amps.
Pretty sure you're supposed to write it on the blank stuff.
Oh, it doesn't matter. But you can write it there if you want to. Okay, let's do the bottom one. Here we go. We got what? 120, no, we got 12 volts and 120 amps. It's 3 to 1, and I think Ethan said it was 4 volts, and so did Devontae and a couple others in there. Well, if I got 4 volts, so I got less volts, a third of the volts, what's going to happen with the amount of amps, y'all? By how many times? By 3. 3 times 120? 360. So 360 amps. Is that a little or a lot of amps? That's a lot of amps. Don't put your hands on that thing, all right? Okay, so that's how these work. We're going to see tomorrow, all right, everybody from 9E, we're going to see tomorrow how they use these in electric power plants. So I'll try and get my demo working. I'm sorry I couldn't get it going. I'm not happy, but that's it for today. So everybody here, can you help me put up the chairs? Everybody at home, we'll see you for the live stream tomorrow. Okay, bye-bye.